Welcome to my YouTube channel. In this video we are going to do design of pile cap using robot structural analysis. Before going for the demonstration, let we see the input required for pile cap design. The input required are geotechnical or soil investigation report comprises of pile capacity in tension, compression, lateral forces, pile type and diameter, foundation loadings which is to be defined through foundation layout and primary load values such as sulfate, live load, wind load, seismic, snow or any other loads. Standards to be followed for design, either it is a BIS, Eurocode, American or Russian or any other local or any other nationalized standards to be followed for load combination materials and design. Other input for documentation such as project name, owner prepared and checked by. Now let me go for demonstration. Now you can see in the screen there is a foundation layout. It is a sample foundation layout which we are going to have for this demonstration purpose. And in this you can see there are 4 number of a pile cap of size 1 meter by 3 meter and 600 mm is a thickness of the pile cap. Those are connected by tie beams of size width is 300 mm and deep is 600 mm. The pile diameter is 600 mm. All the pile cap are placed in 4 meter by 4 meter center to center distance respectively. So now what I am doing is I am going to generate a grid line like this, having 14 numbers of grid lines on both x and y direction respectively. The grid line are generally made where there is a edge of the pile cap and at the center of the pile and the column. So likewise there are 14 grid line. So while doing the model in robot structure we need this grid line formation. So let we go into the modeling of our pile cap along with the foundation layout as shown here in the picture in the robot structure. Now you can see on the window it is a new landing page of robot structure analysis. In this I need to click new. I need to select shell design which is in the top third icon from the left. So the window will be opening like this and I am going to do the axis definition. So as you see the grid lines are increment by 500 in both the y and x axis up to 3 meter and after that 1 meter is increment from 3 to 4. After that again it is increment by 500 mm up to 7 meter. So likewise I am going to make a grid in a robot. So first one is 0 in x profile. So before going to create I need to click this axis definition which is in the top most icon in the right hand side. So here you need to select Cartesian and x. In x I am going to numbering in alphabet which is 0, first one, 1, 1.5, 3. So up to 3 meter increment is 0.5, after that 1 meter. So again 4.5, 5, 5.5, 6, 6.5 and finally 7. Next one is y. For y axis the numbering shall be in numerical values. So first one grid is 0, 1, 1.5, 3, 3.5, 4, 3.5 won't be there, 4.5, 5, 5.5, 6, 6.5, 7. And in z direction only 0. let it be select as a value, and I'm applying here. You can see in the window the axis. Now I am keeping this XY direction, Z is in 0. So this is perfect for me to create my pile cap and pile. Now if you see how to draw the pile cap, so based upon my grid which I marked earlier, I need to draw a pile cap using this grid. So for that I need to click the fourth icon in the right hand side. I need to click again floor. So here I need to select rectangle, and here in the model shell, the thickness, as we had seen that the thickness of the pile cap shall be 600 mm. So I am clicking this three dot. I am typing here 600. Parallelly I am changing this label name also. My grade is showing something different to that which I am required. So I am selecting M25, which is in Indian standard, adding this. So before all this, I need to go for standard description. For that I need to go job preference. So here material I am selecting Indian. So the grade of concrete is M25 I am creating. Next one is in database. Steel timber, we no need to worry because we are not going to design steel or timber. And for design codes, by default it is having some European code. We need to select it to Indian code. We can select only in RC structures as we are going to do design in concrete. So here in the list, if we see IS 456 2000 is for concrete design, so I am selecting that. And for load and load combination, for me it should be Indian. So IS 875 part 5, and the remaining thing we are not going to define or calculate directly using the code. We are just calculating based upon the manual, so no need to worry about it, no need to change. And let me save this as a current parameters as default, and then OK. So now I can draw my pile cap. So I am clicking here again. So we already formed the thickness of slab here as a 600. I am selecting this, and this should be model should be shell. Selecting rectangular and clicking the geometry. So this is the first point where we want to pick. For my axis I need to draw the pile cap. My first pile cap is start at A12 grid, and G12. So one pile cap is created. Next pile cap start from J14 and L14, J8. The third one is start from C7, E7, C1, E1. The fourth one is start in H5 to N5 and H3 to N3. So now I had created the 4 pile cap. Then after that I need to create the pile. So for that I need to click fourth icon in the right hand side. Here I need to click circular as our pile is a circular. So here the center and radius I am picking. For the pile we need to create discretization also. So I am going to create a discretization with 10 edges. And here we need to select a contour or opening. So now I am going to pick my first point, which is laid in B11 grid, and I need to type the radius. So I am picking now the first point, and the radius is 0.3. Applying, you can see the discretized opening now. So next I need to create a node number. First node I am creating in the mid. You can also click in the bottom icon node visualizations to view the node numbers. So I am forming a node in every segment. So we already discretized as a 10. The first number is in node number is in middle of the pile. So the total node should be 11. Now we need to create rigid links. Rigid links is nothing but it is a connection between all the nodes of the pile where entire force to be transferred to one single node. For that we need to go geometry, additional attributes, and click this rigid link. We need to create a rigid link where this links should be fixed, that is it should be blocked in all the direction. So you need to tick or select all this ux, uy, uz, rx, ry, rz, and let me create a new name. That let me call this pile. Adding this, so now I need to define the master node. Master node will be the center of the pile. So one is a node which is at the center, and remaining all the slave nodes. So I am entering 2 to 11 here, applying. So you can see here the rigid link is created now. Next one is we need to define the support condition. So I'm clicking here supports in the right hand side icon. I need to create a new support condition. Let I can rename it as file. I'm selecting this elastic as it is going inside the soil. So I am untick all this. Now I need to find out the elastic stiffness in KZ direction. So for that I am clicking this elastic coefficient, and based upon my soil report I am having elastic silts as a first layer. Second layer is gravel sand clay. Let me assume some soil, and it is a flexible condition, and I am considering a estimated foundation load as 100 kN, and it is a assumed value, and the size of the foundation I am assuming as 2 by 2. After entering this input, assumed input, I am getting the KZ value. Click OK. You can find the KZ value here. So I am adding this as a label pile. So this I am going to assign for support node 1. Apply. Now let me check whether the support is assigned or not. So I am clicking this 3D view. So you can see here there is a image like sigma. So that is a support which we had assigned, elastic support. Next I want to do copy paste of this file and file parameter to all other location also. So for that I am keeping this view xy. So I am selecting all the file parameters and going in the top menu you can see edit. I am clicking that. In that you can see in the second icon, move or copy. I am clicking this. I am just picking the center of the file and moving to the other location. Now it is copied. Similar like I am doing all for all the file cap. I4, M4. So I had created all the file. So let me close this. So next I am going to create a tie beam. For that you need to click the icon in the right hand side, seventh icon. So after clicking this it will be open like this small window. So for that I need to select the beams, RC beam. Here the section I need to define the size. I need to click this three dot, RC beam M25 grade I am selecting, and it is a rectangular one, and the size shall be 300 wide and 600 deep. So this is added here, add it, then close. So my size is assigned RC beam. Now I need to draw the beam between the center of all the pile like this. Now 4 beams are drawn. You can see the view of this. So I need to display the bar shapes and the panel thickness. So you can see here now. So entire file cap model is developed. So in the right hand side you can see the PDF file. So in the left hand side you can see the robot window, which is showing the exactly what it is in the file layout, that is a foundation layout in the right hand side. So finally we had created the model. So let me close this. Next I am going to rename the node number. So for that I am selecting the center node of file first. So let me rename this as start from 101. So my pile center nodes are start from 101 to 108. Next I need to create a node number for column where I need to apply the loads. So I am start my column nodes from node number 201. So the column nodes are exactly at D11, K11, D4 and K4. So next we are going to apply the loads. So for that let me access can be hide. So you can see in the right hand side there is a tabular format showing the 4 loads, basic loads, dead load, live load, wind load in X and wind load in Y. So first let me create the load type. For that you need to go to loads, click the load type, creating, adding this dead load, live load, wind in X, wind in Y, loads again, load table. So here for the dead load I am considering self weight of all the beams and pile cap. Next dead load is as per the table. So in that table we already known that node numbers for column is start from 201 to 204. So let me make my window. So I am going to apply the dead load as per the table showing in the right hand side. So for the self weight, dead load from the structure I am going to apply on the node where my node start from 201 to 204. There is no f of x, f of y, and f of z is a vertical load. You can see the vertical force defined in n value as it is a downward minus 10.24. So I am having 1.2 of a moment also in x direction, 1.6 in y direction also. Similarly, like I am going to apply the live load. So the node number is the same as above. So likewise all the loads are applied as per the table. Here f of y and f of x are the horizontal forces and f of z is the vertical forces. Cx and cy are respective moments. So you can also view the loads. So those are applied on the nodes. So now we need to go for load combination. For that, loads manual combinations. So I'm defining here 201 as my first ULS load combination. Click OK. So I'm selecting the dead load, live load. The load combination factor you can type here, or if it is auto means we need to define here. So my dead load and live load I am considering 1.5. If I need to change this factor also, you can change by typing here the values and click the change. So if I am typing 1.2 here and click the change, the dead load factor will change. Similarly, if I am selecting the live load and type 1.2 and click the change, it will change. So you can do like this, and for wind also you can change like this with record. So now automatic means it will take that value. I am combined the live load, dead load and wind X. So you can see here. Now again I am creating a new ULS combinations 202, ULS2. Again I am combining dead load, live load and wind X. Applying. Next one is a serviceability load. I am adding 101 SLS1. Clicking here. SLS doesn't have any factor, it is a 1 only. Similar like I am creating 101 also, 102 for other directional wind. So the load combination is done now. So now you can also find the load combination here. So SLS1, SLS2, ULS1, ULS2. So all those value you can also see here. So next one is we need to do the discretization of element. So for that you need to click here. In the top menu you can see options of FE mesh generation, that you need to click. Again here generation of calculation model. So it will create a mesh type of element. Now you need to assign the design parameters. So for that you need to click the design menu. In that, for pile cap you need to select required reinforcement of slabs or walls, code parameter. You can define this requirement. As in a structure model means it will select from the structure model, or else you can untick this and select your parameters. So likewise you need to give the parameter for all the pile cap. So now if you select pile cap, it is showing that material and all those descriptions are related to this pile. So this calculation purpose, this should be in shell, and you can select all the pile cap and need to select this as RC shell. Then you need to select all the beams, tie beams. So here in the instead of bar it should be select as beam. So now your model is ready to go for design. So you can select here for beams, and for tie beams you need to define the code parameters. So I am going to use this RC beam. So here I am going to assign the beam parameters. So for that I need to select the bar number here in the left bottom. So for RCB means it should be consider member number 15 to 18. Clicking apply. Now this tie beam are designed as a RC beam. So now you can directly click required reinforcement of slabs or walls, and you can run the calculation procedure. So now in the right hand side you can see the area A in X minus means it is a bottom. I am applying here and I am selecting the value. You can find out here 720 square meter, 720 square mm of reinforcement is required for this pile cap. For at this edge near to the pile it is 916. So likewise you need to design the pile. You need to decide the pile cap reinforcement. So similar like in Y direction bottom, X direction top, Y direction top, you can find out the reinforcement area. For the spacing for defined diameter, you can see it is required at least 150 mm of spacing. So next we need to design the tie beam. So for that again you need to go design RC beams columns. So you need to select the members 15 to 18. Yes. And the load cases you need to select by clicking this 3 dot combination, adding this, and the next adding this. For SLS case also, and applying calculation, then you can close this. You can see in the left hand side bottom menu the reinforcement information. Top reinforcement required 322 square mm. Bottom reinforcement required 322 square mm same. So the top reinforcement diameter also given as two numbers of 16, and in the bottom it is two number of 16 again. So now even the stirrup or lateral ties reinforcement also provided here. 6 mm is sufficient at 180. So that's all about this pile cap design. So you can also find out the reactions and other parameters by clicking the result and reaction, and the displacement you can find out from here. If you want to know only the SLS combination means you need to select the load combination 101 and 102, which is SLS combination. So similar like we need to, if you want to find out any plate shell result also, that is possible. And if you want to know the moment or other stress value, you can select and find out like this. If you want to know the value, you can click the values. And if you want to find the moment, you can click here in Y, X. So that's all about this session. Thank you for watching. Thank you. Please look into the description for more related videos.